Hello, good day. I'm Guanzon from Group 2. My topic is all about global circulation of the atmosphere. Contents: atmospheric circulation, spheres of atmosphere, the three models of atmospheric circulation. Number one is Hadley cell, Ferrel cell, and polar cell. The patterns in global air condition, season, monsoon, day and night, sea breeze, and land breeze. The purpose of this presentation is to introduce the topic of atmospheric circulation. The main concept is the atmospheric circulation is a response to differences in insulations between low and high latitudes. There is a transfer of energy from low to high latitudes. The global patterns of surface winds and pressure belts returns from his circulations. There is a seasonal shift of the surface wind and pressure belts. What is atmospheric circulation? The circulation of wind in the atmosphere is driven by the rotation of the earth and the incoming energy from the sun. Wind circulates in each hemisphere in three distinct cells, which help transfer energy and heat from the equator to the poles. Spheres of atmosphere. Troposphere extend to 16 to 18 km above the tropics but less than 10 km above the pole. Contains 80% of atmosphere's mass and runs to hydrological cycle because tropospheric temperatures decrease with height. Like that, the three model of atmospheric circulation. Hadley cell. The Hadley cell, named after George Hadley, is a global-scale tropical atmospheric circulation that features air rising near the equator, flowing the poleward at 10 to 15 kilometers above the surface, descending in the subtropics, and then returning equatorward near the surface. These circulations creates the trade winds, tropical rain belts and hurricanes, subtropical deserts, and jet streams. That is the example. Hadley cell. Ferrel cell. The Ferrel cell occurs between 30 and 60 degrees north and south. The Ferrel cell is dependent from its existence upon the Hadley cell and the polar cell. It comes about as a result of the high and low pressures as the mid latitudes. For this reason is it sometimes known as the zone of mixing. In this cell is higher levels that winds blows equatorwards and in westerly direction and polewards and in an easterly direction of the surface. This is the example of fair cell, like that. Polar cell. This polar this cell occurs at 60 degrees north and south. The air has been warmed up the rises upwards, creating a zone of high pressure, though cool, creating a zone of low pressure, though cool and dry relatives to equatorial air. Air masses are the cells sufficiently warm and moist to undergo convection. When the air reaches the polar areas, it has cooled considerably and descends as a cold dry and pressure area, moving away from the pole along the surface. This is the example of polar cells. 60 degree, 30 degree, below 60, 60 degree north and south. Interaction with each other cell. This is the example. Hadley cell, Ferrel cell, and polar front. Patterns in global air circulation. The polar easterlies, polar high, polar cell, air rises, air falls, air rises, air falls, and air rises. Ferrel cell, horse latitudes, Hadley cell, doldrums, Hadley cell, horse latitudes, and so on. The patterns in global air circulations. Trade winds, westerlies, polar easterlies. Trade winds trade winds blow in a belt lying between 5 north to 30 south in southern hemisphere. Polar easterlies The polar easterlies blow from the polar high pressure area to the temperature low pressure area. Whisperlies The whisperlies Wisterlies The westerlies winds blow across the latitude 35 to 60 of both hemispheres. Westerlies, trade winds, and westerlies, polar easterlies, and polar easterlies. Atmospheric Atmospheric circulation is different in seasonally, summer and winter. Monsoon. Monsoon is traditionally defined as a seasonal reversing with wind accom- accompanied by our corresponding changes in precipitation, but is now used to describe seasonal changes in atmospheric circulation and precipitation associated with the asymmetric heating and land sea. Rain. Rain. Examples sa summer and winter. Conclusion. Atmospheric circulation is the large-scale movement of air by which heat is distributed on the surface of the earth. The circulation of wind in the atmosphere is driven by the rotation of the earth and the incoming energy from the sun. Without atmospheric circulation, earth is static. Thank you.